Welcome to everybody. Probability and stochastic processes, operations on one random variable. In this session, we will see moments. I am Dr. V. Ayyambillai, Professor ECE, GRIT, Hyderabad, India. First, let's see moments about the origin. G of capital X is equal to capital X to the power small n, where n is equal to 0, 1, 2, and so on, defines a function of capital X. The nth moment about the origin is defined as the moment of the original random variable. The original random variable is an unshifted random variable. M n subscripted is equal to E of capital X to the power n is equal to integral of minus infinity to infinity small x to the power n fx of x dx. Specifically, m naught is equal to E of capital X to the power 0 is equal to minus infinity to infinity small x to the power 0 fx of x dx, which happens to be equal to integral of minus infinity to infinity fx of x dx, which was seen to be equal to 1. Next, m1 is equal to E of capital X to the power 1 is equal to E of capital X. Next, let's see central moments. Central moments are moments about mean. Capital X minus m capital X is a random variable. After removing mean from the original random variable capital X. This is a random variable whose origin is shifted to the mean. Since for the original random variable origin is not shifted, we call the moment of the original random variable as moment with respect to origin. The new random variable we call as random variable with respect to mean or center. The expectation we call as central moment or moment about mean. The central moment is defined as follows. Central moment is notated as mu small n, mu naught is equal to 1 and mu1 is equal to 0. This can be seen by putting into the general expression as follows. E of g of capital X is equal to E of x minus x bar the whole power n is equal to integral of minus infinity to infinity small x minus capital X bar the whole power n fx of x dx, where n is equal to 0, 1, 2 and so on. The second central moment is significant and has been given a special name. It is variance. Variance is statistical expectation of the square of the spread of the basic random variable with respect to mean. That is what we call it as E of capital X minus x bar the whole squared. The statistical expectation of the spread with respect to mean is 0. That is E of capital X minus x bar is equal to 0. Hence, it is not a useful parameter. Variance of capital X is also written as var of capital X, that is VAR of capital X is equal to expectation of capital X minus x bar the whole squared, which is equal to integral of minus infinity to infinity small x minus x bar the whole squared, that is integral of minus infinity to infinity small x minus capital X bar the whole squared fx of x dx. Another useful parameter is the positive square root of variance. It is called standard deviation. Please note that standard deviation is not the statistical average of deviation with respect to mean. Standard deviation is equal to plus of square root of VAR. That is, we are not going to take minus square root of VAR. A formula for variance. E of capital X minus X bar the whole squared is equal to based on A minus B the whole squared E of x squared minus 2 capital X x bar plus x bar squared is equal to E of capital X squared minus E of 2 capital X bar plus E of capital X bar squared. This is equal to E of capital X squared minus 2 capital X bar into E of capital X plus E of capital X bar squared, which is equal to E of capital X squared minus 2 x bar because E of x is nothing but x bar plus x bar squared because expectation of x bar squared, which is a constant, is equal to x bar squared. This is equal to E of x squared minus 2x bar squared plus x bar squared, which is equal to E of x squared minus x bar squared, which can also be written as m2 minus m1 squared.